And we are live. Welcome to my Chronofold in Purescript stream number 11. I'm Junchan, and we are pretty much ready to go, except for a little bit of music, because that would be nice. And we will hear fireworks going off, because even though it seems like it's been forbidden, I think this year because of Corona and probably the likelihood that people set off fireworks and they're gathering. But yeah. Berliners are not necessarily known for their where they're accepting top-down orders coming like that. So anyway, let's see. Am I good here? I believe I am. So we are still implementing the causal tree merge algorithm, and so that's what we'll continue with today, and I'll probably come back after dinner and I don't know, maybe stream a game or or some working on streaming tools. We shall see. And so here is our code, and our tests for Node. Tells us that one of our replicas, we've been following the example that's in the data laced with history blog post from Archegon, and which uses this Control-Alt-Del example here, and turns out that in fact our replicas 1 and 2 actually do seem to properly equal Control-Alt-Del, which is what we want. It checks replication with conflicts. Yes, those two tests are for now are just placeholders. So indeed, both one log Control-Alt-Del, which is the state of site 1 after it received all the ops, and 2 log Control-Alt-Del, which is the same for site 2, are both equal to Control-Alt-Del, but 3 log is not. So let's focus back on this and try and understand why that's not the case. And I think it should probably be useful to show the 2 ops del and the 1 ops backspace to TRL. That should help us troubleshoot what's up. And we're probably going to have to do sort of a step-by-step tracing to figure out what's going on. Okay. Oh, for some reason, this triggered a recompile of many things. That's pretty strange. But here we go. so we already have some some tracing statements, and those are two ops array, and so the two ops del, so 1 is alpha, 2 is beta, and 3 is gamma in this notation. So beta indeed is 2, and so 2 ops del would be, I suppose, D, E, and L. And we also have one ops CTR, one ops backspace to TRL that has the backspace here, and a second backspace, that's why it's 2, backspace 2, and then TRL. And we see both have the same parent, causal tree parent, CT parent, which means they're CT sibling, and they're not only they're CT sibling with each other, but there's also another one of those sitting in the 3log control alt, 3log command alt. So we'll actually also print that one. This way we'll have the full view. There we go. And so here we have right, alpha 1, 2, 3, 4, and gamma 5, 6, 7. Oh, yeah, right. 3log CMD is and side 3. It's the result of the 3 alpha characters coming from CMD plus the root. So that's alpha 1, 2, 3, 4, and that's why we have alpha 1, 2, 3, 4 here. And then together with ALT that's been written on side 3, and that's gamma 5, 6, 7. And it should be the case that gamma 5 has as a causal parent alpha 4. And we should see that by looking at here, just alpha 4 has gamma 5. We reverted the map, or inverted the map, made it so that the parent is the key, so that we could simply just check whether something is there. And that probably will need to be cleaned up. There's a number of optimizations, but before getting to those, I just want to make sure that I get the key algorithms right, even if it's with a slightly bloaty implementation for the first go at it. Okay, so in theory, what happens when first of all beta comes in, and we should probably try and see what happens when we only add beta. So this would help us figure out. So yeah, let's definitely do that. We'll actually just append the first and probably project that. And we don't need to show because project is a string, and but we'll need to append the ops. And so we only append the 2 ops del. So maybe it makes sense to put it here for now. And we'll put this guy up here after this. Right. So we start with the 3log CMD ALT, and then those 2 ops del. We apply the 2 ops del, and then we show the remaining ops coming from site 1, and then we show the result. And I don't need to append here again because we already have this here. And so saving should just work. So right, so what this tells us is that after we got command alt and we applied 2 ops del, then we have command del alt. Why? Because del is meant to be inserted after alpha 4, or with alpha 4 as a parent, so right after D. And replica 2 has precedence over replica 3 because we just pick an arbitrary order, and the first replica has the most priority, and then the next one don't, which I guess makes sense as an arbitrary order because it means that in some sense the creator of the document, which it depends how we allocate replica IDs, I suppose. But if we did so by saying that the original author of the document gets replica 1, then I guess it kind of makes okay sense to say that that person has priority, even though it shouldn't matter that much. It does matter, though. It'd be interesting to shift things around, meaning if site 3 did the delete there. So that's a nice and interesting test to run. So I'm going to add another placeholder with conflicts, and we'll say variation. And this should do just a tiny bit of housekeeping here. This should be same as above, but with site 3 doing the backspace times 2 TRL. Okay, so what do we have? Right, so it makes sense that after we've appended 2 ops del, that the result is command del alt, because 2 has priority over 3. So that's good. However, when we then move on to the next set of ops, which is the alpha ones, in this case, we would want alpha to have priority. Oh. Hold on, this actually makes sense. That it would be controlled del alt. Since del has priority. I guess maybe that's this is not a very detailed, this is not a complete sequence diagram. It doesn't explain exactly who receives what and when. So it could be, well, I mean, in any case, we have a problem because everything should converge to the same value. But now I'm just realizing that since site 2 has priority over site 3, then it shouldn't be ALT first. But because there's this 7 here instead of a 6, maybe that's the trick there, that in fact site 3 has received something afterwards. Somehow afterwards, conceptually. Is there a way we can check this here? So CMD and site 1, and then D. Yeah, there's a kind of an interleaving here, which I haven't properly replicated in this test here, which is that site 2 inserts D at 6, and then at the same time site 1 inserts a delete. with index 1. I don't know what these indexes are, in fact. It's actually the second delete here. Huh. Is it the local position? It's probably the local position. Yeah, 0, 1, 2. Delete goes back to 1. Yeah. And then, well, another delete should actually go back to 0 here. So, no, that's not... I'm not sure where this... what this index is supposed to be here. Okay, maybe this will be clearer with this. So CMD, this delete has a parent as parent M. That is strange. That to me is not the parent. Okay, D has parent M, that's fine, but why would the delete... Is there a special case for deletes? I don't think that that's the case. It should be depending on D here. CTRL. Oh. Yeah, I'm not convinced here. About what's going on here. This seems to penalize local insertions, so I'm not sure. And remember that this paper, this blog post predates the Chronofold paper. But maybe before I go back to trying to interpret what's happening here, I should make it so that this example actually converges, because right now it doesn't even converge, and so obviously that's buggy. So why doesn't it converge? So the fact that it's DEL ALT and that it outputs CTRL DEL ALT actually makes sense. If we consider that site 2 has priority over site 3. So it means that this is not the case that we really need to troubleshoot. The case that we need to troubleshoot is one of the other two. Okay, so let's try and troubleshoot 1, CTRL, LTDLT, LTDL. And I'm not going to rename those yet, even though they probably should at some point. Okay, so we show, yeah, we don't need those. And so we start by showing well, let's log let's project one log CTRL LTDL, and I think that is currently Control Alt Del, not Control Del Alt. I don't understand why it's rebuilding again. strangeness. ALTDL, yeah, control alt L. Okay, so, and in truth, let's trace this. So we'd want to take a look at one log CTRL, because that's the base thing. And then we want to look at the 2ops DEL, which is the first thing we append. And then we want to look at one log CTRL with 2ops DEL appended. And then we'll want to look at 3ops ALT, and that we don't have yet. And then finally project the result. Looks good. Let's give that a shot. So okay, that's a bunch of SPI debug tracements or trace statements. Okay, so alpha 9 should be one log CTRL. Yeah, with only alphas in it. And well, we probably want to project this, although, I mean, like just for the sake of completion, and then we'll also want to, or if we project, then if we append the ops, then we actually want to project this. Okay. That starts here, and okay, so alpha, after doing its 9 ops, ends at CTRL, and that's fine, right? It gets there by doing a bunch of backspace here, 2 backspace after writing MD, right? So 0, CMD, 2 backspace, and TRL. So that's fine, and we have a contiguous CT structure. And then we show our 2ops del, and so that's a beta 5 that depends on alpha 4, and that's the DEL here that we're reading for, so DEL. And then when we project this, it becomes control del, which looks perfectly fine. And then the gamma operations are also appended at alpha 4. And here, however, is where we're bumping into an issue, and that is that ALT shouldn't have precedence over beta, so it should append after beta. Oh, right. So, in fact, when I do my trick of detecting or updating this map in which I keep the city parents. I'm storing the highest priority branch, so it means that when gamma gets compared to alpha, it doesn't even care about beta. Whereas it should insert itself right after beta. So that's interesting. So that's a kind of a, what is it? It's not the least upper bound, it's the reverse of that, right? It's the greatest lower bound. Yeah. So when I'm doing my priority ref comparison, so it means that actually the max isn't really what matters, is it? And it hints at the fact that we kind of, I mean, at least in my implementation, before doing those optimization again, we might actually want to well, surely not to update with the max, but maybe we don't update at all. But then what would the logic look like? And maybe I need to start getting rid of that ref data structure, which I think is possible with but requires quite a bit of Oh, well, I'm going to be right back. I need to put some. I need to put a sweater on because my nose is sniffling. Be right back. Okay, I'm back. So if we use this map, could we replace, if we say we'd had instead an array here, we find the same key, then if there's another children, then we need to add it. Yeah, let's start with that. I mean, it's kind of doubling down on this data structure that we know we're not going to keep, but hey, that's fine. And it makes sense from a data structure point of view, right? We have the key, which is the parent, and then it can have multiple children. So it needs to map to an array of timestamps. And then we use the refactoring superpowers. Okay, we don't really care about that. I mean the tests, okay. There we go. So that's, yeah, sure, that's one of the ones. Is that the only one? It can't be the only one. Well, we don't use that array in the buffer, but maybe it's the first one that it detects. Oh yeah, right here, uref. So here we, so yeah, well, it would depend how we sort them, and based on if there's already, if the parent already has a kid, then we compare to the what? To the last one? We're going to order them in priority. That makes sense. And so we compare to the last one. Oh, well, we need to do a sort, because we can receive them in any order. And if we had, let's say, alpha 5 and gamma 5 in there, then we need to insert beta 5 in the right spot. So we could just sort the array, right? And so in this case, we don't need to do the comparison here. I mean, we do a comparison because we're sorting. But here we can just sort, and then maybe then when we look up here, then we can use well, we compare with the array to figure out where we are, and then we'll do our work with the one that's just before us in the order. So trying to think about the fact that here we use ref in here and not new ref. That's also something maybe a little bit strange, because presumably we've added things here, we've added it already. So maybe we'll be able to better separate these two things here by looking up in new ref after we've added it. Okay, so look it up. This is now an array. So these are really siblings. So then we just we take a look at the array sorting functions. This inserts an element into a sorted array. Hey, that's exactly what we want. So siblings with only one element, we can consider it as sorted. And we do have an order. Well, yeah, exactly. We have an ordering. So I think we're we could say we're not detecting the equality case. I'm not sure what happens when we insert a duplicate in an array. It probably won't matter. So, well. So what we do, we insert oh yeah, we insert at opref. So this is the map, and what we do is that and this is the array, and we insert t, I believe, in siblings. Right, now we have two inserts, and so this needs to be array insert. And right, in this case, if we have nothing, oh, then we just insert a singleton t. Okay, so we probably have an error up there now. Yep. So is there a CT sibling? So that's siblings now. So we can say, are there CT siblings? But we want to check in new ref, I think. And now if we have a sibling, then we want to know which element is the one just before us in the siblings array. So we find ourselves LM index of t in siblings, and we take the element just before if it exists. So if it doesn't exist, then so it's the same. It's basically the same idea behind our compare here, I think. Except it will give us an index value. Well, I think we can do it in this way, I think. So here, let's see, LM index returns a maybe int. So it means that if this is okay, how do I? Okay, no, I'll do this later. This is so annoying. This. So if so we find ourselves I think we want to be in the maybe monad here. So that's what, that's our sibling rank, our sibling, our pos, our sibling index. Because then we want to check if there's something just before that. And so that's just a regular the regular index. So we do siblings at our sibling index -1. So that's our adjacent older sibling. Our older sibling. But if this so yeah, what about the invariance? Is this ever going to be, I mean, this could get us to a nothing, and we kind of don't want that. So we want to explicitly deal with this. So we'll do maybe, because if our sibling index -1 doesn't exist, then we just take the, oh well, then in fact we just take we do care about what the older sibling is, right? I think that that's what we want to pass to priority ref here. So I think it's identity and apply. So then this is used as a default. Sorry about that. Let's see. Oh, but then that means no, that means that we so we do need to case on this actually. Okay. Because in this case, we want to go down this branch here. So we're going to case on this. And I think this is just priority ref. And then we do this. But if actually there's no older sibling, then we have higher priority. So we just insert and relink as usual. Right. Like this. And now we don't detect anymore we're inserting the same thing twice. And let's just delete. Okay. LM index comes from data array. We can use it qualified. Yeah, hold on. Oh, right. The do notation here is actually causing us trouble. In that I need to run the maybe at some point. Array with maybe. That's right. Because we're returning the new next. And we're in a maybe. Okay, maybe I just don't know how to do this properly. So let's just do it like so. Which in fact means that we need to consider that we are not in the siblings array, and that would be an invariant violation. So let's throw an exception. New ref. Okay, we just inserted T in your ref. Yeah. And it compiles. And we have something different. I have control command alt dtrl. Okay. Yeah, that's quite different. So let's spy on our siblings. Let's spy on our siblings. Okay. Ooh. Yeah, you're... Oh, right. This is pattern matching. I can't do this here. I need to do it. Let's see. Yeah, here we do. Yeah, a little bit of a Berlin firework warm-up. Okay, siblings. You know what? Yeah, no, that's... So this is what? This is... oh, well, that looks like that's sorted in the reverse order that I would expect. So well, that's strange because I thought I fixed my ord instance. And we are using insert. Insert T in siblings. T is a timestamp, and T should have this ord instance of reverse. Oh, right. So maybe in this case, we can retrieve the regular one, in fact. Because then the older is upwards in the array. So that's, and we get Control-Del out, which is not what we want, but at least so this is sorted. And so is this. So this is alpha 5 and beta 5. And so when we insert, here we should be inserting after alpha 5. Which should be our priority ref. So let's check that our priority ref is where it's supposed to be. And then maybe let's remove some of the noise and say that this is just A, I believe, right? Yeah. And then also do a little bit of a change just right here. Something happened with my keyboard again. Maybe I didn't add this keyboard shortcut actually. Yeah, that's just where it is. Okay. So yes, so we can avoid doing this, then we need to not do this, and then and then we can just do it here. That's the log, and it's not the show instance though. I mean, it's not the projection. Well, for now it's fine, I think. Okay, so more step by step. So one CTRL is this, it's CTRL, that's fine. We get the beta operation, so now we see, oh, there's an alpha 4 parent, and it already has an alpha 5 sibling. And so we're like, okay, alpha 5 is the priority ref. That sounds good to me. And so it means that we end up with CTRL DL. Yeah, exactly. So no issue for me there. So hold on, maybe we need to actually be bolder and check these two guys out. This one and this one, and we can move it here. Here we have Control Del Alt, Control Del Alt. I think that's actually what we want. Hey, we converged. All right. That's good. And then I suppose we can just sort of reverse our replicas and then have Control Alt Del if we want to. I think it's interesting that this is actually I mean, there's this 7 here, which, yeah, which potentially indicate that site 3 actually occurs maybe after it's, I don't even know how to interpret that. Because we can't say that it's after it's seen one deletion of D. Can't say that. Because it would be CMALT. So that's 7 here. I'm not quite sure. And now I just feel that this is probably not worth putting so much more effort into. Because we converge, yay, and so in fact our we equal to Control Del Alt, which is not the usual gimmick, but it is what it is, and we can remove our tracing commits, I believe. And we have some more. And we pass. And so let's do a couple more tests, variations, however we want to call that. Didn't want to do that. Oh, right, that's nothing yet. Okay, so this variation should be what? Doing our site 3 doing the backspace. Okay, sure. Why not? Let's remove this and let's copy this, but we'll make it a bit terser if we can. At least by removing the comments. Maybe also being less generous. Oh, right. So now what did I say we had? We have site 3 doing what site 1 was doing before. So really what we're saying, well, yeah, I mean, I think this is really what we're saying. And let's and this might not be control del. Ah, well, no, it should. No, it won't be. It might be. It might be control alt del right there. In fact, unknown type replica in test data Chronofold. Oh, I see. Seems like I've actually saved something here, which maybe I shouldn't have, but that's fine. We will indeed. That will be the next step to do the property testing. There's a cycle. Well, oh. Well, we can just import types if we want. Yeah. And or for instance, is that a warning or an error? And that's an error. Well then let's not work on this quite yet. Okay. Okay, Command Alt DTRL is what shows up here. Why? So this is going to be a little bit confusing because now we actually have replica 3 doing CMD blah. So yeah, so I think this was a little simplistic, but as long as the 3 are equal is really what matters. So I do want to check. I mean, it's really one of the important things. I do want to check whether the 3 are equal or not. Log show, log project. Yes, 3 are equal. Wonderful. We still converge, but let's rewrite the test properly as I intended. Okay. So we start the same way, but it's site 3 that's going to do the deletion. In which case it should be Command Alt CTRL that comes out if we... Huh. Yeah, no, I'm not sure what I want to do here, actually. I'm confusing myself. I think I just want to revert site 2 and 3, and then that should just be Control Alt Del, and then we do property testing. How about that? Control Alt Del. So I think it makes sense to call it a variation, because this is kind of the thing that we'd actually want to see. Oh, I called it the same. No, what did I? Oh, I have a true equal false still lying around. And 2 tests passed. Lovely. And we'll also, as we are we'll reactivate the other ones. Yes. Now we change the internal representation, and that means that this guy actually has an array here. Which is all good. It's as expected, right? Yeah. And 3 out of 8 tests. Ooh. Ooh, not good. We've broken our previous examples. Regression alert. Maybe it's our build causal op that needs to be changed now. This should be depending on the timestamp for P. Okay, well, let's check out these. So I suppose it's going to be pins then instead of insk. Okay, but pins backspace. okay, this is not what I want to see. I want to see beta log Pinsk. I want to see the op. No, the op. Then I don't mind seeing the results indeed. The op is beta 7 depending on alpha 2. Yeah, that sounds right. And then, well, we do want the projection. Oh, beta log Pinsk backspace equals Pinsk. I see. What? That is strange. So here, supposedly, we've appended beta up backspace. Okay, so I must have messed up the regular path. So when we get to, I wonder whether this is related to what I was saying here about where the delete actually occurs. So we have this beta 7 op. It's coming in, and its opref is just alpha 2. So opref prime is alpha 2. And then we check whether ndx-inv which ndx-inv is the before to last array, so it's this guy. Right, we check whether we're inserting at the end, and we're not inserting at the end. Okay, so we're in false. So there might be a preemptive CT sibling here if we're not inserting at the end. And so we look up opref in the new ref, and opref is, well, it's just alpha 2. And just alpha 2 should have alpha 3 in it. But new ref should actually have already inserted its thing, like so. And so new ref would have checked whether opref is in ref, and it would be like, yeah, there are siblings here, there's alpha 3. And then it would be inserting at the same key, just alpha 3, a new array which includes the inserted t, which is beta 7. So now we should have alpha 3, comma beta 7 in siblings. And so new ref. And so therefore when we look up the OP ref in new ref, this should be alpha 3, comma beta 7. And I'm going to take a note of that. And so now we are checking what's up in this array, and specifically our index. And our index is 2. And so our sibling index should be 2. And so when we do our sibling index minus 1, or let's say in a zero-based array, which it really is, so our sibling index is 1, and our sibling index minus 1 is 0. And so when we check what's in there, there's alpha 3. And so priority ref should be alpha 3. And that is to say that alpha 3 has priority over us. Which I guess sounds fine to me. And so then we go into the next prime case. And priority ref is alpha 3. Already there's something a little bit strange about the fact that we're not using the 3. We're just carrying it. We're just using the alpha here. So that's already a bit strange. And yeah, I think that's where we probably want to not insert at end, but insert at call it pi. Sure, why not? Ooh, and we're blowing up the stack. So not that then. Okay, let's see. So we're looking up alpha 3 in NDXM here. And NDXM is the map. That's right here. And so we're looking up alpha 3 in here, and that tells us 2. Okay, so that's 2. And then we find the last index. Oh, yeah. Yeah, my logic was we insert it at the end, but that doesn't make sense, or it doesn't work. think I needed to have a visual representation of this because I actually didn't do it properly. I mean, I tried here, but this isn't working. So let's see if we do it just based on this particular execution steps, then 2 indeed is the priority. Or so after 2 we want to insert whatever we just found, which seems like that's exactly this. No, that's at the end. So it's kind of what I was doing before. Oh no, yeah, we're looking up here at prime here. So it's okay. Let's try this. What I'm saying is that I'd be executing this instead. Okay, so that does fix Minsk, but it doesn't fix now it breaks our it breaks the blog example. Okay, so still something I'm not understanding properly, it looks like. Command Alt DTRL. Is there something special with even tombstone operation and CT serve an important organizational role? Insert B to the right of A does not change its meaning even in the presence of concurrent operation, so long as A is a tombstone in case it's deleted. So is this is something I still haven't figured out, and it looks like probably, right? I mean, very probably. So M leaves a tombstone after it's deleted. That's fine. Let's see if there's something I missed around deletions. Deleted characters get marked with tombstones, but that's in the root case. So how about let's see with tombstone. No. about backspace? No. And here, so this is, yeah, Insk and then Minsk, that's correct. So what could be the difference? I mean, I'm close to the root. It could be that it's actually something that's creating some trouble. Let's reinsert our code. And maybe, in fact, check out what our next prime and spy up looks like. Okay, so 0 PINSK. That's the backspace. Okay, let's first check that we're breaking the test again. I mean, yeah, we are, okay. And because after we apply beta 7, for some reason we get exactly the same result. Because I suppose we've inserted beta 7 at the very end. Shouldn't this even be pins rather than Pinsk? Oh, right. Okay, I see. That's because of the projection code. And the projection code, I think, let's double check it. Projection code, when it's at this, yeah, it mutates, but it doesn't delete. Is that right? The accumulator has its last character removed, or it should be. we take the accumulator of its length. Okay, I think this is now I see that there is a library function for that, isn't there? Isn't it drop or drop end? Yeah, it's drop end. So drop end 1, I think. Oh, ACK is a string. Right. So there isn't a drop in string. That's why I'm doing this crazy thing. Yeah. Okay. So I'm using split at split. It's not even here. Yeah, we just don't have a drop end. For strings. That sounds like something that could easily be contributed. Oh, there was a drop right. There used to be a drop right. But there isn't anymore for some reason. It depends on code unit. Interesting. cu.drop. Huh, how come? Strip suffix caret to char. Okay, there is a drop right. But it's in code unit. Why? This is really confusing. Really confusing. Okay. Drop right one ACK. Drop right from string code unit. Okay, well, it builds. It still doesn't explain why we don't get rid of the K here. We end up with beta 7, beta 8. Yeah, right, hold on. With only the backspace, you have beta 7 here. And so when we look at the next, yeah, I guess we see infinity and we just bail out. So it's about our recursion here. Because we're at the last thing, we end up not even checking CP, whereas I suppose we just need to. And so here we need to return drop one right ACK. So that's an edge case, not addressed in the most beautiful way, but it's now addressed. Pence. Yeah, I mean that's super ugly, but let's not obsess on it right now. The real problem is that we do this weird thing with how we append, or how we relink the linked list. Okay, so I mean, our pref is alpha 3, but then we end up doing our insert after the last of the alphas coming from alpha 3, which doesn't make sense. So, or it doesn't make sense for these tests, right? It works with our conflicts. So let's say that well, that's what I just did earlier, right? So let's redo that and let's rethink again our relinking in the case of the most sophisticated problem. So we can hide these guys. In fact, we might want to altogether There must be a way to deactivate tests, but that's still probably the most fastest. Replication with conflicts. This is where we are. And I've deleted a lot of my debugging stuff. Okay. All right, so let's log show. One log CTRL. And then the appending of those two, and then and before that the 2. Okay. And you want a apply. Okay, so we have CMD 2 backspace. Hold on. 1 log CTRL. I guess we want to project that. So yeah, so that's CTRL written with 1, 2 backspaces. So it's a CMD, 2 backspaces, and TRL. Okay. So then when we say that our beta operation actually depends on alpha 4, we're saying that it's coming after the D, because we haven't dealt with the deletes yet. But that's not how it's written here, and so need to pay attention to this again. CMD, and then site 1 does a delete, which for some reason nobody else is linked to. Site 2, oh yes, I think I get it. I think that it's related to the way that I'm building this operation right there. I'm appending it at the end. I'm appending these backspaces in the array. But I should be doing this step by step, I think. Or at least there's, that this is where, because indeed the last delete depends on the last letter, but then the next one, which the timestamp is strange here. Yeah, in this timestamp, it's like instead of having deleted from the end, it deleted from M, and then it went right and deleted D. So this I think should be T7 and T6, but whatever the case, I think in my case I'm stringing my deletes. I'm making my delete depend on my delete, and that's wrong. So, And it's wrong because it's just what a matter of actually saying that we skip. So it is that tombstones are dealt with specifically in a different way. Huh. Because when I'm inserting M and then D, what about TRL? These are supposed to be site 1 T, site 1 R, site 1 L. Yeah, so those are supposed to be in sequence, and they are in sequence. But yeah, when we delete, then we have to do something special in the relinking of the weave. I think that's the lesson here. So, but do we need to change the, or we need to do something in the building of the ops when there's a backspace? Because here we said beta 5 depend on alpha. Hold on, what am I looking at here? I should be looking at one ops backspace to TRL, but I'm looking at two ops del instead, and two ops del. Yeah, I mean, there's no issue there. That's not where the problem lies. I can do this thing, that's fine. The problem is, I think, with one ops backspace to TRL. And so it's really before the one log TRL. It's really in here that this code point 8 is alpha 1, 2, 3, 4, 5. And alpha 5 depends so that alpha 4 D has as its children alpha 5, the backspace. Alpha 4 has its children alpha 5, the backspace. But alpha 5 doesn't have children. Huh. Which is another way to say that this is wrong. I mean, if no, that's not the problem. The problem is that when I do, I think the second delete, and my second delete shouldn't have as parent the first delete. That's where the whole problem is. Yeah. So it is to say that, in fact, this backspace affects alpha 3. And so alpha 3 should have both alpha 4, which is D. Huh. How does that work? And how come this is not specified here? Is this just in the CT paper and I just take a look at that? What's the good CT paper? So maybe the authors is that the Git repo or what? 8? Yeah, that's the Git repo. Is this just say it here as well? Delete. Given cause order, assuming the deleted character persists until any operation that references the map processed, the intent of this operation is not cumulative. Insert A at index 0. Right, no, I don't want to, we can't use indices, as we said, so insert A after B, given causal order, assuming the deleted character. The deleted characters persist until any operation that references them are processed. I'm not sure what that means. Okay, RGA, CRDT, Tombstone. 2016. Tombstone removed elements. So it seems like it is indeed a special case. RGA, monotonically increasing number and replicate identifier. It's our timestamps. Just permanently tag our elements from our vertex. Okay, so it's the product of this pointer with whatever is or with a maybe blah, and the option is because of the root. Is that right? Instead, is the catch element is of option type Y. In case of else, virtual pointers were generated to reflect a global lexical order that matches the insertion order. They were not related to each other in any way. In case of RGA, pointers are smaller and of fixed size, but they're not enough to describe insertion order alone. Instead, insert event refers to preceding virtual pointer. For this reason, we cannot simply remove them, since we don't know if another user is using them as a reference point for their own insert at the moment. Instead of deleting them permanently, RGA put Tombstone in place of removed element. Yeah. So that's your option. Your option is a Tombstone. Is that what it is? Huh. That sounds like something else. And then we have what? Command and operation, and the command is insert something of something at a certain index, the value, and the value, well, okay. It's not, why are we're not dealing with vertices here, okay. And so the command is either insert the blah or remove the blah, okay. So, right, so it means that our backspace op is a special op, okay. And then the operation is not the command, the operation, what is that, the local thing? maybe that's the conversion between the what I call my shared coordinates space to a local coordinate space, because these are time-stamped, and this would be, yeah, that's right, yeah, that's the local operation, and that's the operation converted to be sent through the wire. And because RGI inserts relate to the previous element, the sequence of our own insert will be linked together, preventing from interleaving with someone else's inserts. Okay. How are we going to put first element since there are no predecessors? We put invisibility. Okay, so that's our origin or root. In this implementation, we're using an ordinary array of vertices, but in practice, it's possible to split metadata and content into different structures, so that's the co-structure thing, or use specialized tree-based structures, like ropes, to make insert-remove operations more efficient. Now, how the insertion itself should look like. First, we need to find an actual index where predecessor affixated element can be found, and just insert an element a new next index. Sounds simple, but this is one crucial edge case. Two actors concurrently insert different elements. Okay, so that's the merge thing. And we use our virtual pointer, extend them with one important property. We make them ordered. Yeah, first by sequence number, then replica ID. Oh. Really? Well, that's not my ordering. I'm doing replica ID, then sequence number. Could that be part of the problem here? I mean, okay, let's look at this continuous, and then Alice inserts U, insert at 0.6a U with the timestamp 10a, fine, that's the op. Bob inserts 6a n, it calls it 10b, fine. And then A receives B's operation, Bob's operation. And it keeps the insert point unchanged because we have priority, or because B has priority, well, arbitrarily. And then here we shift it because, again, B has priority. So we say A comes after. Where does it make sense? Virtual point. Well, remember, when generating new virtual pointers, we take a sequence number as the highest possible value. Also, since our RGA is operation based, we can count on the events being applied in partial order. When inserting element C after A inside collection AB, we can be sure that B, a virtual pointer, is defined to two categories. B's pointer has sequence number lesser than C, which means we can be sure B was inserted before C. Or B pointer sequence number equal or greater than C, that means that B has been inserted concurrently on another replica. In this case, we'll also compare replica ID to ensure that virtual pointers can be either lesser or greater to each other, but never equal. This way, we even when having partially ordered log of event, we can still guarantee that elements inside of RJ itself remain in total order. Yeah. Another indirect advantage of having CIDT backed by a log of events is that we can travel over entire history. Yeah. This check is performed recursively, can be written as follow. Which check are you talking about now? I guess that's the merge. Yeah, that's the code for the merge, okay. So it just does offset +1, and it actually does some kind of shift there. But that's RGA, not Chronofold, so maybe that's just the way it is. Yeah, I mean, the insertion. With this, we can implement our insert operation as apply inserted with a predecessor and a pointer and a value and an RGA. Find the index for the predecessor vertex can be found. Adjust the index when new vertex to be inserted. Update RGA to store the highest sequence number. Since it's done, the hard part is now over. We can get to removing elements at provided index, which we already described. A simple blah. Oh, we really need this to mark a particular. Okay, yeah. So removing elements at provided index. Yeah. So apply removed. Find the index where remove vertex can be found, and tombstone it. Where remove vertex can be found, blah. That's the at, and then RGA vertex. Array replace index at none. Oh, none is our option there. Okay, I see. So there's a mutation there. Oh. All we really need is to mark a particular vertex at tombstone, hit on by clearance constant to none, yeah. And skip them over when materializing our CRDT to user-facing data structure. Skip empty vertices. What is this, Swift or Rust? I don't even know what programming language this is. F sharp? Oh, is it F sharp? It's quite pretty. Must be F sharp. C sharp. Yeah, so that's credible. Must be F sharp. State-based CRDD, optimize state-based, introduction to state-based CRDT. In F sharp, yeah. Huh. Yeah, it's quite pretty. I quite like it, I gotta say. Okay, so tombstone in this case mutates the RGA log, which feels wrong to me. It's because, but maybe it's fine. CRDT has RGA in it. And it's an array. It's an array of vertices. That's really what it is, right? And RGA puts tombstone is in place of removed elements. So in this case, it means we put it. I think it's not clear how tombstones are dealt with here. I'm still not. I mean, now that we know how tombstones are done in RGA, then maybe we'll understand OT with tombstones. Okay, M points to the tombstone, and then P is linked to the I. But maybe we don't link the tombstone to the P. But well, no. Then we need to relink P to the root if we keep a doubly linked list, which might not be what we need. I mean, it's not really doubly linked list. Let's look at the Rust implementation. Okay, well, that's what it is. Backspace. Nope. Applies it up to the Chronofold. Get the ref. Okay, the op can have no reference. I suppose that's for the root. But if we have a reference, then we self-log we look at the index for that inside. Okay, so that gives us the index, so that's a local, that's the local reference, and then we apply the change at this reference. And apply change takes this ID, which is a timestamp, the reference, which is an option, and the change, which is the value. We find the predecessor, which I guess is the parent, and we set the predecessor's next index to our new changes index while keeping its previous next index for ourselves. So that's the relinking. And then we append the things with this relinking here. And nothing about backspace. So is that then when we read the, is it like in session, like when we're, it's an editing session? There's some splicing going on. So there seems to be nothing. Okay, what about tests? Basic features. Full scars, vec clear, full session clear. Okay, that's clear. What? Oh, okay. No, not clear actually. Is empty. Like what's assert element CQ? Okay, so that's a helper function. It takes initial values, a mutate vector, a mutate chronofold. It just means a mutable vec and a mutable g. A mutable vec gets the values. So it's a mutation on the vector, right? That's a lambda, I think. Lambda functions, they call them closures. Yep, that's correct. So that's a mutation, so that's done, and then the mutation of the chronofold is done, and then there's an assert such that the iteration of the vector is the same as the element in the chronofold. So that's kind of some correspondence between the chronofold operations and local operations, I think. Oh, it's to keep a sort of isomorphism between a vec interface to the chronofold Right, so that's a vec, that's the vec-like thing, and you're just checking that it does the natural thing. Okay, I see. It's interesting. Both delete the same single character. So there is a remove instance. So maybe that's what I need to look at. Let's remove. Right, session, is it? Oh, I need to remap this. This is annoying. Yeah. Session. Remove. Remove the element with log index from the Chronofold. Note that this just marks the element as deleted, not actually modify the log apart from appending a change delete. So that is a specific operation. And so where is that used? Deletes have priority. Aha. So find predecessor, which was used when we were applying the change. Get the reference and the change. And we got a predecessor from it. And so here it says that when we find the predecessor, then if actually the change that we got is a delete, then we return the reference directly. Saying that deletes have priority. That sounds strange. And this is not reading deletes. But not reading delete maybe makes sense. If it's not a delete, then we check. I suppose this is the conflict change, right? This must be the is there another city parent, and then iter subtree then gets into the conflict resolution. And iterate over the log of indices in causal order. That's a smart move. But when do we do this on append, right? So we use it to, or we return the last. So that sounds like what I was doing with my branches, right? And so maybe that's fine. And that's just so that deletes are the weird thing. So in that case, we're saying that indeed, that's fine, but that we need to deal with deletes somehow. That passes, and what we want is to just do the simple replication test, because that's the one that should fail. So it probably means that we don't deal with deletes here. We deal with deletes. I'm going to close this. What's up here? And so now we're saying we're actually matching on deletes in the append op. And we're saying something like we're bypassing we are saying something like if it's a delete, we actually don't do the whole tree thing. And so how do we so let's say we detect, we still need to detect whether there's a sibling or not. Oh no, we don't. But we might not be appending at the end. But here it seems like we can look up in the op ref. Okay, I'm gonna do something I'm going to hate myself for, but I'm going to use ifs and else. Okay, v, if v, and what was our from enum of v, I think. From enum of v. Oh, we could say to enum of this as well. Equals to enum of blah. Then we do this swap, I think. And we do basically this case. Oh, right. Right, it's better to do from enum. I think that's the direction which doesn't have the maybe. Is that right? Oh, I need to import this. Yeah, okay. Oh. Deletes have priority. Oh boy. Yeah, fireworks. I agree. Hey. Ain't that lovely? Awesome. Well, Sir Dominic Kellner, thank you very much. Well done for the delete tab priority. I couldn't figure that out. And I don't see where it's here either. Deleted characters get marked with tombstones. Keep the deleted pieces in their place. Yeah. Maybe requires prior knowledge on tombstones. I mean, maybe it's similar to what we were seeing here. Removing elements as providing index is simple. So it's the simple case. We just link it. We just link it simply. We don't follow the subtree. Yeah. Delete tab priority. We don't need to follow the subtree. And so this iterator on subtrees, that's quite elegant. It's I mean, I don't know if it's going to help us or not. I mean, this is already fairly, yeah, this is bloated, right? But let's commit it, because, and let's also actually check it in the browser. Make sure all works. And it does. It's that runner is even able to get us the log, in fact. And so before we commit, then we're going to remove all of this logging. Oh, hold on, it's not here. No, that looks like spying. There it is. That should be just A. And this is so ugly. I think I need to, this is getting even uglier, and so I think after I set up doc tests, I kind of want to de-uglify. It's a thing. It's a thing I just made up now, but it's a thing. I kind of want to do a benchmark as well. I mean, I know I said I would prototype, but I think I'm... I want to kind of have a really basic benchmark. Let's see, what do people do for benchmarks these days? They use benchmark. So let's do that. And then we will prototype before we de-uglify. But we might need to do some... Okay, I'll say that I'll do more property tests after I do some kind of prototyping thing. So what does that mean? First, let's check that we don't have other spy statements. I don't think we do. Let's also make sure that our tree is clear of warnings. We shouldn't have non-empty things being used here. What happened there? Ah, right, okay. Yes, sure. Okay, I shouldn't have touched this file. There's no point, I don't think, yet in doing so. This is the file I wanted to touch. Okay. Fine, I'll fix the import suggestions. It doesn't really hurt. Okay. And let's commit. Git commit. Chronofold converges. Okay, well, it's going to rerun the tests, and I'm happy with that. And yeah, benchmarks, that's going to be fun. So usually that's in a bench thing. Yep, that's right. And so git. Oh, what did I commit before? Yeah, I didn't. What did I do? I didn't add. Import benchmarks. Import data.chronofold. What's FN here? It is recommended that you use rollup plugin first to improve performance and produce accurate benchmarks. Oh, there's an example here. That's very nice. I haven't seen this name before. Per simple benchmark. Okay, and the build steps. Yeah, roll up instead of parcel. Can we do roll up and parcel? No, right? And I remember seeing stuff with, yeah, like there's also the Clojure, the Google Clojure compiler. Clojure, JavaScript, Purescript, Clojure compiler. Okay, that's what? That's vendored? It is vendored. That is strange. The Conquer is pretty awesome. And so that does use parcel. And so does it use parcel and roll up? Is that a thing? A Java jar prod. Yeah, it uses the Clojure compiler in prod. Just the regular Spago bundler. But I think this doesn't optimize all the things that that we might want. There was a thread on this, Clojure compiler. Okay, well that's interesting, but there was something recent. Okay, maybe not that recent. Yeah, that's probably it. Ah, yeah, that's it. So there was something potentially being discussed. So, and I think I haven't subscribed to that, so I'll definitely subscribe to that. Yeah, the uncurring problem, I remember hearing other people complain about this, that if it was possible to remove closures, then things would be fast. Roll a plugin purse. There's something that does this. I mean, I kind of want a baseline with my code in any case. So let's see. How is this supposed to be ran? Let's pick a thing that has benchmarks. I think free has benchmarks, but I'm not sure what that's using. Benchmark main Benchotron. Let's use this. Okay, Benchotron. What is this? Benchmark.js. With graphs. Okay, so HDGarrod is obviously a well-known quantity. I mean, sorry, didn't mean to. Reduce a person to a quantity, but I just mean to say HDGarrod is a name I've seen quite a lot. So I would tend to think that even though this benchmark here is here. Oh, Liam Goodacker, that also maybe it's been uploaded later then. That actually hasn't been updated in a while, whereas Benchotron is version 7. Okay, so we know what we're doing, I believe. And well, in fact, let's take the whole thing, no? Or maybe see if there's some. Oh, yeah, there's an example here. It looks like it's probably the same, but we know this one compiles for sure. So we'll save this and we'll spago install Benchotron. Is a funny name. Oh, hey, you're doing weird things with the command line here. And we need to spago build, but now we have this new thing. And so what's the way that usually these things are built? Well, this actually isn't tested. Maybe it is tested here. It doesn't look like it is. That's a little bit sad, but maybe we check free, which we were doing a second ago somewhere. I'm already lost. I think we're saying benchmark template is not gonna make it. There modification. Okay, fine. Free. And how is that run? Build benchmark, build benchmark main. Yeah, not anything particularly crazy. So we'll do benchmark, spago test, main benchmark dot main, I believe. And let's try that. And run benchmark. Benchmark main was not found, and that's because we're not in the source folder, maybe. This is supposed to be main. Oh, okay. Well, let's look again at how free does it specifically. It was in the benchmark folder, wasn't it? Yes. Benchmark main, it was benchmark main. So let's call this benchmark main. And then, I'd be surprised if you can find it. Yeah. So do we need to tell it where things are? Yeah, like, so it knows about test, but okay, well, oh, spago tests. Spago run really is what we mean to do, but let's check out the help and see yeah, path. Minus path, bench. And let's call it bench because nobody can get time for that. Permission denied. How about that? That is strange. Okay, dot slash maybe. Press bin dot slash. Okay, what is this new problem? Include. Is there an include? No, really, source path to include. Open binary file. Why? Is it because of no, it converted my not minus e test benchmark not minus e require output benchmark main.main. Well, that's a pretty right, that's after building it. Yeah, that's fine, but Spago benchmarks. Purescript. Let's see if someone else has done this. Mini bench. Binding to benchmark.js. Follow this to set up. Install benchmark.js locally via npm install benchmark. Yeah, we can do that, but maybe in save dev, npm I, save dev, benchmark. Use Spago to build the program, generating benchmark results. Spago run -m. Benchmark.main. Maybe if I go into bash. npm run bench. Permission denied. That is somewhat strange, but I guess at least consistent. So I'm starting to doubt this path command right there. Sorry about that. How about build? Build doesn't have a path command. That is option -main. Yeah, makes sense. Okay, so maybe we just build bench and then we run we do the node running the node thing like free. What a strange thing. Okay, well, it finds two benchmarks, sum and product. So for some reason, it actually does work. I do have benchmark main. When did it actually build then? And what's the deal with bench? Is it something that's installed by benchmark.js? Benchmark.js. Nope. Yeah, I have no idea how this came to be. Let's delete it. And then if we do just spago build, does it just build it? No. And if we do spago build minus path bench, no. So there's a command that worked, but I don't know which one it was. Oh boy. Okay, well, okay, fine. Main benchmark.main then. Is that sufficient? No. Because there's no main for build for some reason. There is for run, but then it doesn't find it, right? Or yeah, it doesn't find it. So something built it earlier and I missed it. How strange. Oh, could it be just the... Yeah, it's the Purescript, the PSCID that built it. Yeah. Okay, well, fine. Let's not spend much more time on this. Let's just say benchmark and put it with the main code. Delete this and call this just benchmark without the main. And so we know it's going to be built, and therefore we should be able to simply say just build it, and then just go and output benchmark, and that's that, right? npm run bench. Let's make sure. Well, yeah, actually, it should be clear that it's already okay. Oh boy, I deleted the whole app module, but that's okay. That's one of the ones that's not too problematic to delete. Lucky me. I think that's me reaching the point of diminishing returns and needing to eat some dinner. So I'll make sure that that's installed and then leave it there. And I might just come back afterwards because I want to see this thing run now that it's actually in a version that can be ran. And let's look at the right, that's where it runs. So that's super cool. I definitely want that. And how are we going to do this here? Functions, bench. Yeah, that's the one. Okay, do this. And it's running. Stuff going in TMP. And right, it's doing 2000 now. Okay, so that's cool. And what we want is some kind of bench Chronofold, right? And we want to do things like appending. Let's call it Purescript Chronofold because if people publish it sometime. Simple benchmarks of result written to TMP JSON, and what else? That's it. And so right, there's a next step. Next step is upload the don't like that, but fine. Okay. FG renderer. Okay. Well. Next, we will try to run it with some of our code, and we'll probably then keep this implementation, put it in some like naive Chronofold suffix namespace, and then start iterating on improving performance. Well, I mean, depending on what comes out, in fact, I might just start with it and do the prototype as I said I would. All right, so that's it for now. Thanks for watching, and we'll see you next time.